Hello students, welcome to my channel. The topic is thermodynamics. Before going to the topic, please subscribe my channel, press the bell icon for notifications, like, share among your friends and comment. Thermodynamics deals with the study of heat, temperature and its interconversion of heat and other forms of energy. The term thermodynamics was coined by William Thomson in 1749. Here, thermo means heat, dynamics means flow. That means flow of heat and other form of energy is called as thermodynamics. There are various basic terms. Actually, thermodynamics is based on four laws that you already know. Zeroth law of thermodynamics, first law, second law and third law. So these laws govern the principle of thermodynamics, and the quantitative part of thermodynamics is based on these four laws. Next we can see what are the basic terms associated with the thermodynamics. So before going to discuss about that, we should know two terms. One is system and the other term is surroundings. So the system is the part of the universe where the experimental work is carried out is called system. See, for example, if this is the system, this is the system. So the part of the universe where we are carrying the experimental work is called system, and the surrounding means the part of the universe other than the system is called as surroundings. See what happens with this system and surroundings. Both the exchange of mass and energy take place in the system and surroundings that we can discuss with the laws of thermodynamics. Then there are three types of system. First is called open system. The system which can exchange both matter and energy to the surrounding is called as open system. For example, a cup of coffee or tea open in the system which can exchange both matter and energy to the surroundings. Closed system means in this system which can exchange only energy but not matter, or matter cannot be exchanged, only heat or energy can be exchanged with the system is called as closed system. Example, a cup of coffee or tea closed with a lid. Third one is isolated system. The system which cannot exchange or which can neither exchange or no energy to the surrounding is called as an isolated system. So, example for an isolated system is thermos flask. This diagram shows the three type of system like closed system, open system and isolated system. Next we can see the thermodynamic processes. Thermodynamic processes. Isothermal process in which temperature remains constant. Adiabatic process, no heat is exchanged between the system and the surrounding. Isochoric process, the change in volume of thermodynamic system is zero. That means the process takes place at constant volume. As change in volume is zero, so work done is also zero. In a cyclic process, the final state of the system is equal to the initial state. The thermodynamic properties of a system depends on certain parameters. The parameters or variables are classified as state function and path function. State function or state variable are those parameters that depends only on the state of the system and not on the path that they have taken to reach the state is called as state function. Example, temperature of the system. While a path function means depend on the path taken by the system to reach the state. Example, work done by the frictional force. So a state function depends only on the initial and final concentrations, while a path function depends on the path taken to reach the final concentration from the initial concentration. The thermodynamic properties of matter are also classified as intensive and extensive properties. This classification is based on the dependence of property on the size or quantity of matter under consideration. An intensive property is one that does not depend on the mass of the substance or system. Example, temperature, pressure and density. An extensive property of a system depends on the system size or the amount of matter in the system. Example, volume, energy and mass. Next we can see what is internal energy. An energy form inherent in every system is the internal energy. That means every chemical substance has its own energy is called as internal energy. Example for internal energy are rotation energy, vibration energy, potential energy. All these are called as internal energy. So the symbol U is used for the internal energy and the unit of measurement is joule. You know the unit of energy is joule. See, internal energy is a state function of a system and is an extensive property. See, what is change in internal energy? The internal energy of a closed system can be represented as delta U is equal to Q plus W. What is U? U is the change in internal energy of the system during a process and Q is the heat and W is the mechanical work or work done by the system. So change in internal energy, for example, in a reaction A is the reactant convert into B as the product. So what is internal energy change? Delta U is equal to internal energy of products minus internal energy of reactants. Here it shows internal energy, the definition of internal energy and the unit. And internal energy is a state function of a system and is an example for an extensive quantity. For a closed system, the internal energy is essentially defined by delta U is equal to Q plus W. Internal energy change means the difference in internal energies has fixed value and will be independent of the path taken between two states A and B. For the chemical reaction, the change in internal energy may be considered as the difference between the internal energies of the products and that of the reactants. Next is enthalpy. Every chemical substance has its own heat content is called enthalpy. Enthalpy is the sum of internal energy and the product of pressure and volume. That means H is equal to U plus PV. And what is enthalpy change? Delta H is equal to delta U plus P delta V or delta PV. That is change in internal energy and the product of the pressure volume work. At constant temperature, enthalpy H is equal to Q plus W. You know, Q is the heat and W represents work done by the system. As already said, enthalpy is the sum total of internal energy and the product of pressure and volume. H is equal to U plus PV. Enthalpy is not measured directly, however, the change in enthalpy delta H is measured, which is the heat added or lost by the system. It is entirely dependent on the state functions, temperature, pressure, and internal energy. That is why enthalpy change delta H is equal to delta U plus delta PV. At constant temperature, the process heat flow Q is equal to the change in enthalpy, that is represented as delta H is equal to Q. In the next video, we can see about the laws of thermodynamics and their applications. Dear friends, thank you for watching. Don't forget to leave a like and please subscribe my channel.